Hi there, do you have 3 minutes? Yeah? Well, have you ever wondered what the material properties of a Tootsie Roll were? You have? Well, me and my fantastic team have conducted a few experiments to find the stress-strain curve as well as the brittle to ductile transition of this fantastic material, the Tootsie Roll.
For our experiment, we cut the Tootsie Roll to allow it to be held between two beams and measured the inner cross-section to later calculate stress. Extension of the loaded test samples was measured to a marked line using digital calipers. For the uniaxial tensile test, force was added by weighing incremental amounts of water and adding them to a suspended bottle. We then calculated the force by multiplying the hanging mass by the gravitational constant.
A major limitation of the experiment was our access to testing equipment. For example, we did not have an apparatus to provide steadily increasing force, so we approximated the tensile test by using increment in mass instead. This unfortunately meant that we were not able to obtain a continuous stress-strain curve, but instead an approximate one with scattered data points.
Okay, go. There it goes. At the water.
Yeah.
Oh.
While our data produced a scattered plot, our Young's moduli for both experiments were consistent, which increases the validity of our results. We discovered that Tootsie Rolls did not behave elastically under increased loads as they began to show signs of plastic deformation quickly after the load was applied. We estimated the Young's modulus for the initial regions of the graph by plotting a linear fit to the first several points of data. The Young's modulus was found to be 63.5 kilopascals.
Cold Tootsie Roll. Oh! Alright, well, let's try hitting on the hammer too.
When the Tootsie Roll was frozen at approximately negative 18 degrees Celsius and fractured with a blunt force object, the fractured surface exhibited characteristics of a brittle fracture such as smooth, granular surface and a fracture profile with no cup or cone shape. Surprisingly, the room temperature Tootsie Roll also exhibited similar brittle fracture at 21 degrees Celsius. However, when the temperature of the sample was elevated, the fracture characteristics changed to be more ductile, showing signs of plastic deformation and shear.
The butterfly, that's all. Let me see the Tootsie Roll.
Finally, while we were not able to measure the temperature directly of the ductile and brittle fractures, there were noticeable changes which occurred at the two temperatures, which confirms the presence of a ductile to brittle transition temperature, increasing the validity of our results.